Welcome to Lecture 5. Today we're going to talk about how DTensor ops work behind the scenes. We're going to do this at a conceptual level. In the next lecture, we are going to dive into the code and see how it's actually done. So at a high level, whenever we have a DTensor operation, there's a few steps that are taken. So the first step is we need to figure out how to change the placement types of the input tensors. And the reason why we want to do this is twofold. The first reason is because we want to ensure soundness. So we want to make sure that when we do the operations on the local tensor, the output tensor actually makes sense. And the second reason is because we want to minimize the communication and redistribution costs. So oftentimes you'll have a series of potential input placements that will all produce the correct answer, but one of them is going to be the least expensive, and we will typically pick that one. Okay, so after we've changed the input placements, we'll then do the op. And the amazing thing about DTensors is the op is literally just the local tensors and then doing the op. And then lastly, we get an output tensor. And critically, this output tensor may be a different placement type as the input tensors. Okay, so here we're going to go through some examples. The main operator we're going to look at is mapmul. And we're going to go through the first three very quickly, and then we're going to go through the last one very slowly. But the methodology used to understand the last one can be applied to the first three if you're not following along. So the basic idea is if you have a mapmul and the first tensor is sharded by rows, and the second tensor is replicated, when you do the matrix multiplication, your output DTensor, if you work out the math, will also be sharded by rows. If you have a replicated first tensor and a sharded second DTensor that's sharded by columns, when you do the mapmul, you'll get an output DTensor that's sharded by columns. The third one's the simplest. If you have a replicated DTensor and a replicated DTensor, when you do the mapmul, you get a replicated DTensor, because it's as if there wasn't a DTensor at all. Now, the most interesting one is this last one, which is imagine you have a DTensor that's sharded by columns and a DTensor that's sharded by rows. When you do the mapmul, you actually get what's called a partial, which means that the values stored on each rank is actually a little incoherent. It needs to be reduced for it to be, finalized as a value. And we'll see an example here. So, as a refresher, when you do a matrix multiplication, what you're doing is you're taking the rows of the first matrix and you're dot producting it with the columns of the second matrix. And in terms of the dimensionality, if you have an m by k first matrix and a k by n second matrix, when you do the mapmul, the inner dimension disappears and you get an m by n matrix. Okay, so now let's look at a concrete example. Imagine we have 1, 2, 3, 4, mapmul by 5, 6, 7, 8. The way that the math works out is we're going to do 1 times 5 plus 2 times 7 for the very first element. Remember, because it's row, column. And then we're going to do 1 times 6 plus 2 times 8, right? Because it's this first row and then the second column, et cetera, et cetera. Now, if we had DTensors with this sharding, then what this would look like is the column shard. Remember, we're sharding the first tensor by columns. The column shard will be 1, 3, and 2, 4. And then the row shards will be 5, 6, and 7, 8. And so, and then remember, these are GPUs, so the first column of the first tensor and the first row of the second tensor will be stored on the same GPU. So when we do this mapmul, we're going to actually get a 2 by 2 tensor, where we're going to take, that's going to look like this, where basically we do 1 times 5 for the top left, 1 times 6 for the top right, 3 times 5 for the bottom left, and 3 times 6 for the bottom right. And then similarly, for the second rank, we're going to do this. And what you'll notice is that these, if you sum them up, produce this, right? So like if you look at the top left element, 1 times 5 is the top left of here, and then 2 times 7 is top left of here. And so if you summed it up point-wise, you actually get the right number here. And then similarly, 1 times 6 is the top right here, and 2 times 8 is top right here. And if you sum them up, you get the right answer, and so on and so forth. And so this is the reason why if you do a DTensor map mul between a column sharded DTensor and a row sharded DTensor, you'll get a partial placement. And it just kind of magically works out this way. Okay, so that's kind of what I wanted to go through today. Hopefully you can see that you can kind of use the same methodology to derive what would happen for the first three. The high level takeaway I want you to have is that DTensor operations behind the scenes are doing like some clever things to figure out how to change the placement types of the inputs and making sure that the operations are sound and correct. And in the next lecture, we will go into the code and see how this is actually done.